Have you ever looked at a map of the world and felt like you had a pretty good handle on things? Continents, oceans, mountain ranges. It all seems pretty solid, right? But what if I told you that deep beneath our feet, in a place we can't see or touch, a piece of our planet as large as a continent has vanished? This isn't science fiction. This is a real-life geological mystery that has scientists scratching their heads and rewriting what we thought we knew about the very ground we stand on. Today, we're diving deep, literally, into the heart of our planet to uncover one of its most unsettling secrets, the case of the missing mantle. How did we even find out something was gone from a place thousands of kilometers below the surface? And more importantly, where did it go? The story begins not with a shovel, but with something much more powerful: earthquakes. For decades, geologists have used seismic waves, the shock waves generated by earthquakes, as a kind of planetary-scale ultrasound. When an earthquake happens, it sends out different types of waves that travel through the Earth's interior. By measuring how long these waves take to arrive at seismograph stations all around the globe, scientists can build a picture of what they're passing through. Think of it like tapping on a wall to find a stud. A solid wall sounds different from a hollow one. Similarly, seismic waves travel at different speeds through different materials. Hotter, less dense rock slows them down, while colder, denser rock speeds them up. For years, this method gave us our classic textbook model of the Earth: a solid crust, a gooey mantle, and a liquid outer core surrounding a solid inner core. Simple enough. But as technology got better and our seismic imaging became more advanced, a strange and massive anomaly started to appear in the data. In a specific region deep beneath the Pacific Ocean, right at the boundary between the lower mantle and the core, seismic waves were behaving very, very strangely. They were moving much faster than they should have been. This wasn't just a small blip. It was a colossal region, thousands of kilometers wide. The data pointed to something incredibly dense and cold lurking at the bottom of the mantle. But the real shocker came when they mapped it out. It wasn't just a blob of cold material. It looked like something was missing right next to it. A huge volume of the lower mantle, a chunk potentially the size of Australia, just wasn't there. The seismic data showed a void, or at least a region so dramatically different from its surroundings that it looked like a gaping hole in the Earth's interior. The initial reaction in the scientific community was, naturally, skepticism mixed with intense curiosity. How could a piece of the planet itself just disappear? The first theory started flying. Perhaps it was an illusion, a trick of the data caused by our imaging techniques. But as more and more studies from independent teams confirmed the anomaly, that idea was quickly dismissed. This was real. So, what could possibly carve out a continent-sized chunk of the Earth's lower mantle? One of the early ideas revolved around super-plumes. These are massive upwellings of hot rock from the core-mantle boundary, like a giant lava lamp inside the Earth. The theory went that maybe an incredibly powerful superplume had pushed the surrounding mantle material aside, creating this void. It's a plausible idea. We know plumes exist. The ones that created Hawaii and Iceland are just small examples. But the scale of this anomaly was unprecedented. It would have to be a plume of unimaginable power, something far beyond what our models had ever predicted. Another fascinating theory looked back in time, way back hundreds of millions of years. This idea ties into the process of subduction. That's when one tectonic plate, usually an oceanic one, gets forced underneath another and sinks down into the mantle. We can see this happening today all around the Pacific Ring of Fire. The sinking slab of crust is colder and denser than the surrounding mantle, so it sinks like a rock in water. So the what-if here was, what if, over geological eons, a colossal amount of ancient cold oceanic crust had subducted in that area? Imagine billions of tons of rock sinking down, 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 all the way to the bottom of the mantle. As this massive pile of cold, dense material accumulated, it could have displaced the hotter, lighter mantle rock that was originally there, pushing it upwards and outwards. In this scenario, the missing mantle isn't truly gone but has been squeezed out of the way by this gigantic graveyard of ancient tectonic plates. This theory was compelling because it connected a process we can observe on the surface, plate tectonics, with this bizarre mystery deep within the Earth. However, Neither of these theories perfectly fit all the data. The super-plume idea struggled to explain the extreme cold and density of the surrounding region, while the subduction graveyard theory had trouble accounting for the sheer size and distinct shape of the anomaly. The mystery only deepened. Scientists were looking at a puzzle where none of the pieces seemed to fit quite right. They had a clear picture of what was happening. A massive chunk of mantle was gone, replaced by something else, but the why and how remained tantalizingly out of reach. This is where the story takes a truly mind-bending turn. Some researchers began to wonder if they needed to think outside the box, or in this case, outside the planet. What if the answer wasn't something that happened inside the Earth, but something that happened to the Earth? Enter Theia. For those who don't know, Theia is the name given to a hypothetical protoplanet about the size of Mars that scientists believe collided with a very young Earth about 4.5 billion years ago. This cataclysmic event, known as the giant impact hypothesis, is the leading explanation for how our moon was formed. The theory goes that the impact was so immense it vaporized Theia and a large portion of early Earth's mantle. This debris was thrown into orbit and eventually coalesced to form the moon. For a long time, that's where Theia's story ended. It was a hit-and run of cosmic proportions. But a new, audacious theory proposes that Theia didn't entirely vaporize. What if large, dense fragments of Theia's own mantle survived the impact, instead of being blasted into space? What if these massive chunks plunged deep into Earth's primordial molten interior, sinking through our own mantle, until they came to rest on top of the core? If this were true, it would mean that for the last 4.5 billion years, two massive alien continents, remnants of another world, have been sitting at the bottom of our own planet's mantle. These regions, which scientists have nicknamed large low-shear-velocity provinces, or LLVPs, are exactly what we see in the seismic data. They are massive, dense, and chemically distinct from the surrounding mantle. They are the blobs of material right next to our missing mantle region. Under this hypothesis, the mantle isn't missing at all. It was never there to begin with. That space has been occupied since the dawn of our planet by these fragments of Theia. This idea is staggering. It would mean that every time an earthquake shakes the globe, its waves are traveling through the remnants of a long-dead alien world hidden inside our own. This theory, as wild as it sounds, explains a lot. It explains the colossal size of the anomalies. It explains why they are so chemically and thermally different from the rest of the mantle. It even helps explain some oddities in the chemistry of volcanic rocks on the surface, which sometimes show isotopic signatures that don't quite match the rest of the Earth. Signatures that could be a chemical echo of Theia's material being carried up by mantle plumes. Of course, this is still a developing area of research. Proving that these deep Earth blobs are actually pieces of another planet is incredibly difficult. We can't exactly drill down 2,900 kilometers to get a sample. But scientists are using every tool at their disposal, from more sophisticated seismic imaging to complex computer simulations of the giant impact, to detailed geochemical analysis of rocks that may have originated from deep in the mantle. Each new piece of evidence adds another layer to this incredible detective story. We started with a simple observation: seismic waves acting weirdly. That led to the unsettling discovery of a continental-sized hole in our planet's interior. And now, it's led us to the possibility that we are sharing our world with the ghost of another. What does this all mean for us living up here on the surface? Well, these deep structures aren't just passive lumps of rock. They actively influence the behavior of our planet. They anchor the hot mantle plumes that rise to the surface, driving volcanism and shaping the continents. They affect the Earth's magnetic field, which is generated in the liquid core right below them. Understanding these hidden remnants is key to understanding the long-term evolution of our planet, from its violent birth to the dynamic world we know today. It's a powerful reminder that even in the 21st century, our own planet holds secrets more profound and strange than we could ever imagine. There are entire continents of unknown material hidden from view, leftovers from a cosmic collision that gave us our moon. The Earth's deepest secret isn't just a missing piece of mantle. It might just be the presence of another world, buried deep within our own. Thank you so much for joining me on this deep dive into the heart of our planet. Isn't it amazing what we're learning? If you found this as fascinating as I do, please hit that like button and subscribe for more journeys into the mysteries of our universe. Let me know in the comments what you think. Is it a super-plume, a plate graveyard, or the remains of an alien planet? I'd love to hear your theories. Until next time, stay curious.